Okay, Pre-Calculus 30, we are in section 6.3. We are talking about proving identities now. Proving identities. We've talked in 6.2 and 6.1 about verifying statements, okay? Now, verifying statements would be where we would insert a value in for the variable, and we would see if the right side equals the left side, okay? And if the right side does equal the left side, when we put in the same value for the variables on both sides, then that's a verification that this statement is true. Now, proving something is altogether different, okay? Proving something is altogether different. We have to take our statement and we have to work on one side and change it into the other side without treating them as equal to begin with, okay? So proving identities is not about verification. It's not about giving enough examples to convince that this is going to be true for everything. It's actually mathematically stating that this quantity actually does equal this quantity for all possible values of x. And we do that by transforming each side of the statement so that they can look the exact same or equal each other at the end. Now, a little bit of an intro here. If we are proving something, let's say that we're proving something in a court of law, all right? And you know, we have this courtroom situation where we have a defendant who's been charged with something, and we have a prosecutor that's trying to convince the jury of their guilt, okay? So if you have this person over here, let's say Mr. X, okay, is charged with burglary, then the prosecutor, the lawyer that's trying to convince the jury that he did steal something at this store or whatever, can't say, well, I'm going to tell you, jury, right away that this guy is a thief, and so doesn't it make sense that he would have stolen something from this store? So obviously, you know, he's a thief. Well, that's not what you do. You don't say, I think this guy is probably guilty, so you should just, you know, like, you know, he did something bad before, so you should charge him for this crime. No, it's not a verification like, you know, he's a thief before, so he did this one, right? That would be verification. It would be like, I'm plugging a value in. Does this make sense? Yes, it happens. Okay. So in a court of law, we have to build a case, and that's what we're doing in 6.3. We have to build a case. So I have to show, and you have to show, that this quantity over here, okay, on the left side, 1 minus sine squared, is actually the same as this. It would be like saying Mr. X over here, this is Mr. X today, but I am going to give you some reasons to show you that actually Mr. X on the day of the burglary looked exactly like this. These are the same. So it was Mr. X that did the burglary. So we have to build a case, okay? That's what proving identities are. And what we do is we use our already... Okay, so what we do is we use all the mathematical rules that you've learned in your whole math career, your whole math life, okay? We can rearrange things mathematically. We can add or subtract things on the same side, just to the one quantity. You can split things apart, okay? You can multiply by 1. You're not changing anything if you multiply by 1, and I'll show you what that looks like. Multiplying by 1. It can look different ways. And also we use our identities that we've learned. And so I can say right here that 1 minus sine squared x, now if I go over to my identities page, you remember this? Okay. I'm just going to grab this and copy it. So if I go over to my identities page, let's just go back to the beginning. There's 6.2. And 6.2, some more, and 6.2. Where were we? There we go. This is where 6.3. Okay. So if I go over to my identities page, I'm just going to plop that right here. I'm going to try and see how I can rewrite 1 minus sine squared x. Okay? So I'm going to try to change this side by making parts of this, or the whole thing, equal to an identity that I can prove. So I know that 1 minus sine squared x, boy, can I see that anywhere here? Boy, I don't know if I can see that. Well, these aren't all the identities. This is just some difference in double angle. We do have the other ones as well, and I'm going to go over and grab those as well. We have the reciprocal, quotient, and Pythagorean. We know those as well. Awesome. So we can use those, and I think those are maybe the ones we should look at first, actually. And so do I see 1 minus sine squared anywhere? Well, if you look over here, 1 minus sine squared, 1, if I take this sine squared over, because this is identity, so I can rearrange this equation. If I take the sine squared over here, 1 minus sine squared actually could equal cos squared x. It could equal cos squared x. So I could rewrite this as cos squared x. Oh, okay. That's interesting. So why don't I do that? I'm going to rewrite this now as cos squared x. Does this look like this side now? No. I'm not quite done yet, am I? Okay. Now, generally, we're going to just stick with one side and try and fix it. But in this case, I see that this side has a lot of opportunity for me to rewrite in different ways. So I'm actually going to, and you can work on both sides if you want. One of the tips will be that I'm going to suggest to you that you just work on one side at a time. That's definitely going to be one of the tips. But watch this. So I have the opportunity to change sine times cos times cotan into something different. And I'm noticing this right here, cotan. Okay, cotan. Now I can change cotan into, and I see it down here, into cos x over sine x. Okay, let's do that. So I'm going to write this sine x, just leave that there. I'm going to leave cos x there. And I'm going to write this as cos x over sine x. Now, what that does is it opens up a lot of different mathematical simplification opportunities. Like, I have a cos x here multiplied in the numerator. Sorry, that's not what I'm looking for. I have this one, sine x. I have a sine x in the numerator, and I have a sine x in the denominator. And so when you have a factor on top and on the bottom, you can divide those out. That's like sine over sine. And so with those gone, what's left? I'm left with cos x times cos x, which actually equals cos squared x. So what I've done here is notice I have this line here. That's on purpose, that line. That reminds me, and it should remind you, that you're not going to be adding or subtracting things to both sides. Like I can't do this, plus 1, because right now I'm treating them as equal. And you can't treat them as equal. You have to show that they're equal. Make sense? So I have transformed each side into looking like something slightly different, but they're looking like each other now. So if we work backwards now, I can say that 1 minus sine squared x is actually the same as sine x times cos x times cotan. Okay? So this is what we've been doing in 6.1 and 6.2. We've been using our identities, and now we're going to be proving, okay, that one side is the same as the other side. Now, I've got something here that this is something I'm going to encourage you to do. Notice when we finished our work, I always get you to circle your answers, and this is kind of a minor thing. I always try to get my students to have some pride in their mathematical prowess here. So when you're done proving something, instead of circling both sides, this is what we're used to doing. When you're done your proof, to state that you are finished your proof, then you would put, and this is like an old math tradition, you'd put QED at the end of your proof. And that stands for something that's Latin, which is quod erat demonstrandum. Doesn't that sound cool? It stands for what was to be demonstrated, that which was to be demonstrated. Okay? So I have demonstrated the proof. I'm done. Okay? It is complete, sort of thing. So I'm going to put QED at the end of my proofs. I want you to do the same to show me that you're done your work. Okay? All right. So here's some notes on proving. You might want to take some of this down, jot down in your own words or whatever. But here's some initial notes. Okay? And some of these I've mentioned already. So to prove an identity, I'm going to use a blue marker here. To prove an identity is true for all permissible values, it is necessary to express both sides of the identity in equivalent forms. Okay, so to prove, express both sides of the identity in equivalent forms. All right, that's the first and most important note on proving. Number 2, you cannot perform operations across the identity. Or in your textbook, it might show an equal sign, okay? So it's asking, is this equal to this? Don't treat it like an equation, okay? You can't assume it's true while proving it, okay? You're assuming this guy's guilty while trying to prove he's guilty. That doesn't work. So you can do little operations like moving things around, factoring things, right? Rearranging things. You can do things on the one side of the equation or of the proof, but you can't bring it over to the other side, okay? And there are more tips and tricks that I'll give you in this lesson and as we move forward in 6.3 in proving. Okay, so more tips. There are tips and tricks to prove identities, and then we will be noting those soon. All right, so here's one right here. Okay, so again, let's use our knowledge of our identities to rewrite. We'll stick with one side, and the first tip really that I'll show you right now is we're gonna try and attack the more complicated side. That's always the best way to go. You can change both sides at the same time, although sometimes it's easier if you just keep focusing on the more complicated side to strip it down so it looks like the less complicated side. I am going to grab our identities here again, and I'm going to copy those and bring those down. We also have the unit circle here. Okay. Awesome. Okay, let's go back to 100% view here. Beauty. Okay, so let's tackle this one right here, and we're gonna try to rewrite each of these or one of these sides. So let's focus on the left side. To me, it looks a little bit more complicated, doesn't it? We've got tan x, we've got cos x, we're dividing by cosecant. Now, from our reciprocal identities, you see we have a cosecant here. Okay, I know I can change cosecant into 1 over sine. Excuse me, that's great. I know I can rewrite tan as sine over cos. That's awesome too. So I have options, and I'm going to start to attack those options here right now. So I'm going to just focus on the left side. So tan I'm going to rewrite as sine x over cos x. And I'm going to rewrite the cos x that's on top. I'm not going to touch that. Okay? So again, right here, I've rewritten this as a ratio according to my quotient identity. Cosecant is going to be 1 over sine x. Okay? Now, when you're proving this, please be neat. Okay? Please be orderly. Because it can get really, obviously, it can get really complicated and messy. You might miss something. So please try and be as neat and orderly as you can. Also, try and show what you're doing when you do something, because obviously I'm going to be grading your papers and stuff. So when you show your proofs, you have to show me every step. You have to communicate your thinking, just like a good lawyer clearly maps out the prosecution or the defense for the jury, so they completely understand every step. That's what you're going to have to do. So an example would be something like this. When you rewrite this, I would do this. Say, hey, I'm going to now simplify the numerator up top. And guess what? That actually becomes just plain old, actually I'll use this marker, it's a little easier to see. This becomes just plain old sine x on top. See that? Because that's gone. So that's sine x divided by 1 over sine x. Okay? And you can do one step at a time. You can actually do 2 things at once. That's totally fine. I just did the one thing. The second thing I'm going to do is I'm going to obey my mathematical rules. I'm going to remember how to divide by fractions. I'm going to flip and multiply. Remember that? So this now becomes, I'll use a third color here so you can see this. This becomes sine x times sine x over 1. Okay. Okay. So I've got step 1 here, step 2, and this is step 3. I'm getting closer now. So now, I'll use red. Now I've got sine squared x, don't I? Sine x times sine x. And I am super, super close now. I don't have to touch this side because I now can see what I need to do with this. For one final step, I'm able to prove that the left side is the same as the right side. And I don't know if you've seen it, if you see this, but we can use our Pythagorean identity here. And if I take the cosine over to the other side, sine squared x equals 1 minus cos squared x. And remember, the already established identities like these guys here, you can move things over to the other side and you can rearrange those identities. You can. So sine squared is 1 minus cos squared. So I'm going to go ahead and I'm going to do that 1 minus cos squared x. And now you see QED. I'm done. Why? Because I have 1 minus cos squared x equals 1 minus cos squared x. And there you go. That is your first example of proving a trigonometric identity. Okay, congratulations. That's your first one. Any questions about that? My online class now, just pause. Do you have any questions for me? Okay, so I was asked to go over the last step. So let me just do that by showing you that we are constantly rewriting something that can be rewritten according to our identities. So tan x can be rewritten as this. Now I perform a mathematical operation and I divide my common factors. Okay, I'm rewriting cosecant x as 1 over sine x. Rewriting. I'm doing a mathematical operation by multiplying by the reciprocal of 1 over sine. The last step here, sine squared, okay, the last step, going from sine squared to 1 minus cos squared, I am rearranging this Pythagorean identity right here, because we know that cos squared plus sine squared equals 1. And if I were to take the cos x, subtract cos x from both sides, which you can do with established identities, then I have sine squared x equals 1 minus cos. So if I see a sine squared, that means I can rewrite it as 1 minus cos squared, and that's what I did in the last step. All right? All right, here are those tips that I was mentioning. I already shared with you one tip, and that's this one down here. That's this one right here. Manipulate, okay, that is rearrange or rewrite the more complicated side. That is an important tip, okay? And that's usually where we're going to start. And sometimes one side is obviously more complicated than the other. It just means there are more options for rewriting portions of that as, using identities, okay? And so there's lots more we can do with the more complicated side. If you're trying to tear down a complicated side, it's easier than trying to build up a less complicated side, because it's literally you have like, a dozen choices on how you can change this to make it more complicated. That's easy to do, but it's hard to do to try and match the complicated side. So it's easier to take the complicated and strip it down to the less complicated. That's always easier. Okay. You may, at times, want to express all trig functions in terms of sine x or cos x, okay? Then you're going to get some situations where you can multiply, like cos times 1 over cos, maybe, and that multiplies to just 1, so you can simplify that, and so on. So, like I did cotan, right? I wrote that as cos over sine. That's an example. A general tip too, like I showed in the last example, now this doesn't have to happen every time, but I would strongly suggest you manipulate only one side of the equation only, okay? And I tell my students, it's kind of like this. If you're trying to find someone in the dark, let's say you're playing a game, you're in the park or something, and it's dark outside, and you're trying to hide and seek or whatever, and you're trying to find someone, okay? And they're making some kind of noise or something. If they are stationary, you're going to be able to eventually get to them, right, to find them. But let's say it's dark and you're trying to find them, and then you think you know where you're going, and then they move, and then you're totally hooped, and then I gotta readjust my path, and then they move again. I gotta readjust. It takes longer to get there. So sometimes if you have no idea what you're doing and you just change both sides at the time, you might miss one side, might miss the other side. So focus on one side if you can. Of course, there are examples, fairly seldom actually, where it's like, I can see on this side how I can change that to make it look, so you work on both, and that's okay. That is okay. It's a tip, only a tip. Remember, you can choose it or you cannot choose it, but it's a tip that might help. Okay, perform indicated operations. That's always a good one. If you don't know what to do and you can add or subtract or multiply, you can expand or factor or whatever. Add or subtract is the big one. If you can add or subtract, a good idea to do that one, okay? To get a common denominator, add, so you have more division possibilities, more canceling out of factors. That's a good way to simplify. Factor when possible, okay? So indicated operations, factor, then remove common factors from numerator and denominator. That's a way to simplify. And you may need to multiply the denominator by a conjugate. And of course, you're going to multiply both the top and bottom by the conjugate. And I'll explain that one. I'll explain that one soon. This is really like multiplying by 1, and I'll give you an example of that. Like if you multiply, let's say, 1 minus cos x times the top and the bottom, 1 minus cos x over 1 minus cos x is still 1, so you're not actually changing the side, you're just changing how it looks. So I'll give you an example of that. Okay, so let's use some of these tips and tricks, and let's see what we can do. More complicated side, what do you think? Which one's the more complicated side? I would say probably the left side here is more complicated because we've got squareds. I see a 1 minus sine that's going to be squared, so we might have, I could expand this. Cos squared, I could rewrite that as 1 minus sine squared. So I have all sorts of possibilities on the left. I'm going to go with the left. So let's see. Okay. So as I mentioned, I probably could rewrite this using one of my identities. I could rewrite that as 1 minus sine squared, and I'm going to do that. Okay, I'm going to rewrite this as 1 minus sine squared. Over here, I'm going to expand this and see what happens. I'm going to expand this out, which means that I have 1 minus sine all squared. So I'm going to do FOIL method, okay? And that's, of course, going to be looking like this, right? 1 minus sine times 1 minus sine theta. So that's going to be 1 minus 2 sine theta plus sine squared theta. Okay? So now I've done two things. See, I've lots of opportunity here. I've expanded this out. I've performed the indicated operation of squaring. I've rewritten according to my list of identities there. So now what happens? Okay, well, let's see. This is a plus, so I can just remove these brackets. If it was a minus, I'd have to distribute. But a plus, you can just remove the brackets. And now, what do I see? Oh, I have a plus, or I have a positive sine squared and a negative sine squared. So guess what? That adds up to 0. Those are gone. They're just totally gone. Oh, I also have a 1 plus 1. 1 plus 1. So let's rewrite this as 2. And then what do I have left over? Minus 2 sine theta. So you see how we've transformed that into something that looks very different. And then you want to keep your eye on this side and say, hey, am I close? Boy, I'm really close. I see. If I factor a 2 out and show this as 2 times 1 minus sine theta, that's exactly what I have on the other side. Okay? And I am done. Quod erit demonstrandum. That which was to have been demonstrated. Okay? Okay, any questions about that? So you're trying to make it look a little different, right? That's all you're trying to do. You're not changing the nature of the side. You're just trying to make it look different. So now I can say that this original, the left side here, is actually the same as the right side, or it's an identity for all possible values of theta. Okay, so I'm going to move now to some of your homework questions here, and just going to get some practice. And I like these homework questions because they lead you towards they teach you about some of these tips. So factor and simplify, first of all. This is 1A, part of your assignment. Factor and simplify. So let's give this a shot here. Factoring and simplifying. So I can see that on the top, on the numerator here, I have a common factor. I have sine x is a factor in both of these terms. So factoring is what they told us we should do. So I'm going to remove a sine x as a common factor. So I'm going to write this like this. Sine x. I'm going to remove that sine x. And I'm going to be left with, so what are you left with? Well, when you divide this term by sine x, you get 1. It's a minus. When I divide this term right here by sine x, I get cos squared x. And I'm going to rewrite the bottom for now. Okay? And another important thing, please rewrite everything that you don't touch. Don't think, oh, I'm not going to touch it. I'm not going to write it down. I'm going to save it for later and I'll bring it back in later. You end up forgetting about it, okay? Even if it's 1 or 2 times out of 10 times, if you forget to bring it back in, so just take the extra half a second to rewrite. Okay, so now I'm seeing 1 minus cos squared x and sine squared x. Yeah. You see what I'm seeing? So you could transform the bottom into 1 minus cos squared, or you could transform the top into sine squared. Okay? And I'm going to, and yes, you do have to show this. Okay? You have to show this step, because remember, we're laying this out very clearly for the jury here. Okay? I'm the jury. You need to tell me exactly what you're doing. So you need to show me that, hey, I'm using an identity here to rewrite this, Mr. Maxwell. So here you go. I know what I'm doing. Okay, excellent. So now you want to show me this as well. Hey, those are factors. They are gone. The simplification ends up to be, this all boils down to just sine x. So this whole big complicated thing is actually just reduced to sine x. Factor and simplify each rational trigonometric expression. This is the simplification. Okay? So that's question 1A. What about question 2? Okay, so question 2 says this. It says, use factoring to help prove each identity for all permissible values of x. Okay. So use factoring. So we're going to get a chance to do just what we did here before. Do you see that I have a common factor on the left side, which is the more complicated side? So I'm going to transform the left side. And I see that I have a common factor again in both of these terms. This is one single term, even though it's shown as factors. Okay, that's one term. The terms are separated by plus or minus. Okay, so I'm going to take a cos out, cos x. I'm going to be left with 1 plus tan squared x. Okay, and I'm not going to, well, you don't have to rewrite the other side. You can. I would suggest you put a line there to remember that you don't want to bring anything over from one side to the other during this process. Okay. Oh, I'm seeing this 1 plus tan squared. I'm seeing that, and what am I noticing? That is 1 minus tan squared. Oh, what's this? Well, it's 1 plus tan squared. Oh, too bad. That's pretty close, eh? Do I have 1 minus... Did I even write that down right? Oh yeah, sorry, 1. Where did I get minus from? Ooh, weird. 1 plus tan squared. There we go. It is the same. Okay, look at that. What does it equal? Secant squared. Awesome. Why am I going back there? Okay, so guess what? You're going to lay this out very clearly for the jury, and you're going to say this is secant squared x. Okay, now are these the same? Not the same. They are definitely not the same, but we're close. Okay, we're very close. Okay. You can do two things now. You're going to use your reciprocal identities here. And so you can either change cos x into 1 over secant x, or you can change secant squared x into 1 over cosine squared of x. Okay? Doesn't matter. I'm going to do, well, we want to end up with secant, so guess what? I'm going to do 1 over secant. That's equal to cos. And I'm going to multiply that by secant squared x. Okay? This is now secant squared x over secant x, and that simplifies, right? The secant with the squared, I'm just left with secant x. And boom, there you go. QED, you're done. You've got the left side totally equaling the right side, and you're good to go. Okay? So that's where factoring helps us out. You see that common factor? Factor it out. And what are you left with? You're left with a clear identity right here, 1 plus tan squared. Okay, any questions about that? Okay, you guys are doing great. You guys are doing great. Let's follow along. Let's do another strategy here, which is using a common denominator to express the rational expressions as a single term. So a common denominator. So notice that we have an operation here that we can do, but we have to get a common denominator in order to do this. So sine over cos plus secant x. Okay, so I need to get a common denominator, and that's actually, I think, going to be pretty easy here, because if I just rewrite secant x as, what can I rewrite secant x as? 1 over cos x. See that? So now I have a common denominator. It's already there. And so with a common denominator, when you add fractions, you just leave that common denominator and you can add the tops, or you can combine the tops. So this is actually sine x plus 1 over cos x. And all this question is asking you to do is to rewrite these two terms as a single term. So that's the first step in that's one important skill. So in number 3, that's what all they asked you to do, is just to get one single term, one fraction there. Okay? Awesome. Okay, so here's a couple more that I have. And number 4 here says, rewrite the expression secant x minus cos x over tan x in terms of sine and cosine functions only. Another tip that I mentioned before. So let's get some practice with that. Secant x is 1 over cos x. Okay, so I'm going to rewrite the top, the numerator, as this right here. The bottom is tan x, which is equal to sine x over cos x. And if you need to refer to your identity charts there, you go right ahead. You're going to get to a point where you're going to memorize this stuff, and it's going to come real quick to you. Okay, so that's in terms of sine and cos. I am going to simplify this. It doesn't necessarily say simplify, but I think we're going to simplify this because we need to get some practice actually doing some subtractions of fractions, flipping and multiplying, all that sort of stuff. So guess what? That's what I'm going to do. I'm going to take this a step further, and if I asked you to simplify this top, you would have to get a common denominator. So I'm going to actually rewrite this over here now. Okay. And this would be 1 over cos x minus cos x times cos x over cos x. You see, what I've done is I've multiplied the top and bottom by cos x so that I have a common denominator. You see that? Okay. And now, actually, instead of dividing by the fraction, let's do this all in one shot. I'm going to do this, cos x over sine x. I'm going to multiply by the reciprocal of that fraction in the denominator. See that? Okay. All right. So I'm going to do this part first here in the brackets. So what do I have? I have 1 minus cos squared x on top. Do you see that? Over my common denominator of cos x. And I'm going to multiply by what I still have over here. Now I know this looks pretty confusing, but you know what? Take it one step at a time. Do all of your mathematical operations that you can do. And now we have factor situation. So I'm going to do this, cos x over cos x. That divides out to just 1 over 1. Oh, 1 minus cos squared. Boy, what's that? 1 minus cos squared. Well, if we go back here, where's 1 minus cos squared? 1 minus, oh yeah. If I take this cos squared over there, 1 minus cos squared is sine squared. So, guess what? This is sine squared x over sine x. Man, isn't this simplification fun? This is so good. So what's this? Sine squared over sine? Hey, that's just sine x. It's just sine x. So get a load of that, eh? This big mother of a thing right here, that complicate, is just equal to sine x. And that's the whole point of this section. Okay? Look at that. That's amazing. Isn't that great? So great. All right, what else do I have for you here? I have a couple more examples. Okay, a couple more examples, 2 or 3 more examples here. Full lesson. This is a full lesson. You've got the whole shebang here in this one lesson. So number 6, okay? Number 6, expand and simplify. Oh, we've factored, but now we can also perform the indicated operation of multiplication. Sometimes in multiplying things out, you get a new sort of set of functions to deal with, okay? So this one is asking you to take a look at this and multiply this out. So we're going to have to, it's a binomial times binomial. You got to do the FOIL method here. All right? FOIL method. So what is secant times sine? Oh, well. I'm actually going to write secant as 1 over what? 1 over cos. Okay. So when I do this first multiplication, I get 1 over cos times sine x. Okay, that's the first multiplication. I'm going to rewrite that, simplify that a little bit later. I also am going to write secant times plus 1. Well, so plus 1 over cos. when I multiply that, minus tan times sine. Oh boy, tan times sine. Okay, you know what? I'm just going to write tan for now because I don't want to confuse you too much. I'll simplify this next step. And then tan times 1, that's minus tan x. Okay, so whether you write this what I did the first step or not doesn't really matter. I tried to combine steps here, but I don't want to confuse you. So now what I'm going to do is I'm going to show you that this sine times 1 over cos is actually sine x over cos x plus 1 over cos x. This right here, tan, is actually sine x over cos x, isn't it? So this is going to be sine squared x, because I've got sine x times sine x divided by cos x. Okay? Hopefully you can see that. I've rewritten, here I'll write that a little more clear. This tan x right here, this tan x, I've rewritten this as, I'll erase that, I've rewritten this as sine x over cos x. See that? So now here's the simplification, sine times sine over cos. And then minus tan x is minus sine x over cos x. So when you do that, see how you now can rewrite things, and this we're asking for this to be rewritten as a to a primary trig function. So that's sine, cos, or tan. All right. So notice how I have a common denominator in all of these. Okay. So I can rewrite this as all of this over cos x. And I have sine x minus sine x. Okay. So that's gone. Those are gone. And then I have a plus 1 minus sine squared. Oh, 1 minus sine squared. I'm going to leave that up there. And you should see that this now, 1 minus sine squared, is actually equal to cos squared x, because of our trig identities. And of course this just turns into cos x. All right, now I know you're just getting started on this, so maybe I went too fast in a couple of those spots there. Does anyone have any questions about that one? Because it gets a little cramped and a little messy there. But do your FOIL, and then rewrite tan as sine over cos, and secant as 1 over cos, and stuff like that. And then multiply, add your common denominator fractions. You know, try and simplify everything into one piece, divide out factors, and so on. Okay. Okay. Here is one where it looks like. Let me see here. Okay, let's take a look at this example here. Prove that this is an identity for all permissible values. All right. In this example, it's maybe a little difficult to tell which one's the more complicated side. Okay? Okay. Now, could we work on both sides? Yes. If they're equally as complicated, you might want to just work on both sides. It's an option. I'm going to pick one side and do something. Now, I'm going to pick the right side. And the reason why this is because I'm going to show you how to multiply by a conjugate. Okay, one of the tips. So, I'm going to rewrite this left side like this, and I'm going to put my line over here, and I'm going to rewrite this side too, sine x over 1 plus cos x. Now, what I'm going to do is I'm going to try to get a situation where I have a difference of squares. So that's why you want to multiply by a conjugate. If you have two terms here, and you don't have a squared, because 1 minus cos squared would be pretty nice. Right? That would be equal to sine squared. And that would help us out a lot. But I have 1 plus cos. That's nothing. That's nothing. So I'm going to multiply by 1 minus cos x. The conjugate is the same terms but opposite sign. And that's going to yield us a difference of squares when we multiply. Now I know what you're saying. You're saying, Mr. Maxwell, wait. You can't just multiply something. Well, you can if you multiply the top and the bottom by the same thing. Because remember, that's the same as, that's a quantity divided by itself, which is equal to 1. So if I multiply something by 1, I don't change the nature of that thing. Okay? All right. So now what's going to happen? Well, when I multiply these things out, I'm really interested in simplifying and expanding this. I'm not so interested right now in doing this part. So just wait. I'm going to not expand the top. I'm going to not expand the top. I'm going to leave that like this. I'm going to leave it in factored form. And maybe you'll see why in a second. But this over here is 1 minus cos squared x. See? Difference of squares. I FOIL. 1 minus cos x plus cos x minus cos squared x. All right. Okay. Now, a couple things we could do. And I would suggest that, well, really there's only one thing. Let's change this into now sine squared according to our identities. So now I'll change colors again. So now I have sine x times 1 minus cos x all over sine squared x. See, that's sine squared x. Okay. And my final step here would be to simplify this sine x and one of these sine x's get divided out. And so I'm left with 1 minus cos x over sine x. And now I have the right side equaling the left side. Done. Okay. All right. So that's a case where you multiply by a conjugate. Any questions here so far? Okay, we're almost done this big lesson, so I just have one more thing right here. This is from number 11 in your assignment, and what I haven't dealt with yet, one of the things I haven't dealt with is the double angles. Okay, so let's use those double angle identities, which are on this page right here. We're gonna have to use those. So let's bring that in, and I'm gonna throw that down there. Okay, so the double angle identities are, if you can see that, maybe I will make that a bit bigger. The sine of 2x, you see I have options here. That's what sine of 2x equals. A cos of 2x, I have lots of options over here. So let's prove this one, and of course, step 1, choose the more complicated side. That's going to be the left side, because I've got lots of opportunities to perform indicated operations, to rewrite these as identities, right? Got lots of options. So sine of 2x, I'm going to rewrite that as sine x cos x times 2. Okay, 2 sine x cos x. And that's all over cos x. Ooh, that's going to be nice. Ooh, look at that. Love it. Cos of 2x. Okay. Now, we have some choices for cos of 2x, don't we? I've got a sine x on the bottom. Let's see. Should I do this one? Or maybe this one? Oh, this one's got a sine in it. It's got a sine squared in it. I think we have options here. I'm going to try this bottom one. I'm going to try this one. Okay? Because I've got a sine squared here and I've got a sine down here, which might give me some option for some factoring and stuff. So let's try that. So I'm going to write this as 1 minus 2 sine squared x. Okay? 1 minus 2 sine squared x over sine x. Okay. Okay. So it looks like I'm going to be able to do this over here. Okay. I'm going to do that. And I'm going to rewrite this as 2 sine x over here. And again, like, even right now, I can't see the end. I can't see the end here yet. Okay. And you're going to, on most of these, you're going to start doing something and you're going to say, I have no idea what to do next. I don't know where to go. So just think of your tips, think of your identities, start rewriting, adding, subtracting, whatever. So I have an idea of where I'm going to go here, but you might have multiple paths to do this. One path might be really short, one path might be a little longer. But just keep sticking with it, okay, when you prove these. So I've got 2 sine x here, and I've got now over here, what do I have over here? How can I do this? Well, what you could probably do is you could separate this as to 1 over sine x minus 2 sine squared x over sine x. So you could split this up like you would normally do for a fraction, okay? So you could split that up, which I will, so watch. I think this is going to be a good idea, but we'll see. So I've got 1 over sine x. Why do I like that? I like that because of this, 1 over sine x. Look at that. That's why I like that. Minus 2 sine squared x over sine x. Okay. And the other reason why I like this is because I've got a sine squared over sine. That's awesome too. And now I see exactly where I need to go. Okay? Now it makes sense to me. So now I can see it. What can you see, Mr. Maxwell? Well, here you go. Watch this. 2 sine x plus, I'm going to rewrite this as cosecant x. And I'm going to rewrite this as what? Minus 2 sine x. Do you see it now? Do you see it now? Ha! Hopefully. Positive 2 sine x minus 2 sine x. Gone! Like yesterday's, I don't know what. Well, everything from yesterday. Gone. And we have cosecant x. Let's write that properly. Cosecant x. There we go. And that's exactly what I wanted to end up with over here. QED, we're done. All right. How you guys doing? Any questions? It's a big lesson. It's a big lesson. I get it. Big lesson. Okay. Well, look at that. I think that's kind of all I had planned. I got a whole bunch more examples here, but I think I'm going to end the lesson for today because you've got a little bit of an example of everything. I am going to give you an assignment from the text to complete some of these questions that I started here. Give you an assignment from the text. I'm also going to share with you a paper assignment that I'm going to give to my class here too. So that's your lesson on 6.3. Check out www.mrmathwell.com for more videos and resources. I will have that assignment up as well on the website that you can see as well. So that's Proving Identities, section 6.3 in McGraw-Hill Ryerson, Pre-Calculus 12 textbook. You should buy one today. And they aren't paying me to say that. Okay. All right, there you go.